Okay guys, so let's review chapter 8 now. This should be shorter than chapter 7. So first thing we need to talk about are some different types of matter. So you just need to know these categories. So remember, we have pure substances, and that includes elements, so just things straight from the periodic table, and compounds. So elements bonded together, chemically bonded, that have a formula. And then there's mixtures. So we have homogeneous mixtures, which are also called solutions, and that's what this whole chapter was about. And then there's also heterogeneous mixtures. Remember, homogeneous are the ones where you can't see the different parts, but in heterogeneous mixtures you can see the different parts. Okay, so you need to know that. And then you need to know about some units of concentration, how to calculate them. So especially molarity. So remember, molarity is a measure of concentration, and the units of molarity are moles over liters. So in a molarity calculation problem, that is your goal. Your goal is to get moles over liters. Now, often they will not give you moles or liters to start with. They'll give you something else. But you should be able to figure out what part of your problem is going to turn into moles. That's going to be grams. And what part's going to turn into liters. That's going to be milliliters. So the part that turns into moles we want to put on the top. So that's 70 grams of NaCl. And on the bottom, we're going to put the part that's going to turn into liters. So you notice we have something on the top and on the bottom. That's because we want our unit in the end to have something on the top and on the bottom. Okay, so we need to convert grams to moles here. So that means we need to find the molar mass of NaCl. So we need to look on the periodic table, which I have right here. So Na is 22.99 and Cl is 35.45. So 22.99 plus 35.45, and you end up getting 58.44 grams of NaCl per 1 mole of NaCl. And then hopefully you can see that you want to flip this over when you put it into the problem so that grams of NaCl will cross out. And then we're halfway to molarity because now we've got moles on top, and that's what we want. We just need to now make sure we've got liters on the bottom instead of milliliters. So you just need to remember that there are 1,000 milliliters in 1 liter. That's something you should just know. Milliliters will cross out. And then now all I have to do is multiply across the top and multiply across the bottom and then divide those. So let me do that. So we're going to do 70 times 1,000. So that's 70,000 moles NaCl. And then on the bottom, we're going to do 300 times 58.44. That's going to be 17,532. And then we'll divide those. And I got about 4, so 3.99 or 4. So that is the molarity of that solution. And you can write molarity with a capital M, or you can write it as moles / liters. But the test is going to be multiple choice, so it doesn't really matter. All right. Next problem. What will the final concentration be when 400 milliliters of a 1.5 molarity solution of Ki is diluted to 800 milliliters? Okay, so this word is kind of a giveaway because it tells you it's a dilution problem. But even if it doesn't say that, hopefully you can tell that you're changing the concentration. So basically you're adding some water and diluting the solution. If you have a problem and they're giving you 3 different things and they're molarities and volumes, then it's probably a dilution. So just to remind you, the equation for dilution is M1V1 equals M2V2. So we just need to figure out what the different parts of the problem are. So I'm just going to write all those units over here and we'll identify the different parts of the problem. So M1, do they give us M1? Yes, they give us M1. It's 1.5 molarity. We know that's M1 because it's asking for the final concentration. So the final concentration is going to be M2, so that's what we don't know. We're starting with a 1.5 molarity solution. Actually, we're starting with 400 milliliters of a 1.5 molarity solution. So the 400 milliliters is our V1. And then we're diluting it to 800 milliliters. So the 800 milliliters is our V2, our volume. So obviously the capital M's are molarity and the V's are volume. So then we just set it up and do some algebra. So 1.5 molarity times 400 milliliters equals X times 800 milliliters. And then to get X by itself, I just need to divide by 800 milliliters. So that makes that go away on that side. And then this is just simple. I just multiply those two and divide by 800. So we'll just go 1.5 times 400 divided by 800 is 0.75. Okay, and then we should always think about if our answers make sense. So I'm diluting it to about double the volume. So the concentration should be about half of what it was before, which it is. So that makes sense. Okay, and lastly, you need to know a little bit about colligative properties. So remember, colligative properties are properties that just depend on concentration. And specifically, they depend on concentration of particles. Okay, and there were two big ones that we talked about and one that we just mentioned for colligative properties. So you want to remember there's boiling point elevation, so the boiling point increases when you add stuff to water. Freezing point depression, so the freezing point decreases when you add stuff to water. And finally, osmotic pressure. And that's basically the more stuff you have, the more water wants to do osmosis to lower the concentration. So remember, things that have more particles are going to raise the boiling point more. So if you were comparing, say, CaCl2 and NaCl, this one, if you have the same concentration of each, so let's say we have 0.2 molality of each, this one would have a higher boiling point and a lower freezing point, because remember the freezing point goes down, and a higher osmotic pressure. And just a couple things about osmosis. Remember, osmosis is kind of talking about a situation like the one I'm drawing here, where let's say we have a tube and we've got some kind of barrier that water can flow through, and we've got water on both sides. But we've only got, let's say we've got like sugar on this side, and this side is just pure water. So is the water going to flow this way to the left, or is it going to flow to the right? And obviously it's going to flow to the right to lower the concentration of those particles. So what's going to happen is the water level will rise on this side and fall on this side. And then the concentration will be a little bit lower of the sugar or whatever particles we have. That's osmosis. So that's a quick review of Chapter 8. Again, as always, let me know if you have questions, and good luck.